Okay, so let me introduce you to this concept called a file-based system. Congratulations, you've just been employed by the Sunshine Travel Agency. These guys do vacations or holidays, depending on where you're from all around the world, to different places. So if you want to go to Spain, you book it with these guys. You want to go to America, you book it with these guys. So these guys have files. They have a file for bookings. They have a file on their computer which has all the customer information as well. They have another file with a list of different destinations. So let's picture this booking. Let's do customer first. We've got a Mr. John Smith, who's a customer. We've got Mrs. Rachel Smith. They've got a Dr. Doolittle. They've got a Miss Katara. Destinations: Spain, England, nice place to go. France, USA. And now we've got our bookings file. Let me just make this slightly bigger so that I can fit more information. And bookings. Okay. In bookings, Mr. John Smith is going to France. Miss Rachel Ebanks is going to, let's say, USA. Dr. Doolittle has made a booking and he's going to, let's do Sweden. And Mrs. Ang is going to the USA as well. So we're keeping this all on our computer in, let's say, a Microsoft Word file. So this is like in Word, this is a different Word file, So this is our situation. Interesting, but we have some problems. Number one, if I said to you right now, okay, I want you to find me a certain destination. It should be quite easy because we've only got 3 files. So you go to the destination file and you should be able to find England quite easily. But imagine we had 1,000 countries. Imagine we had a destinations Europe, a destinations Africa. So we have different files for each continent. It becomes, I would argue, quite disorganized and hard to find information the more files we have. So that is a negative of us using this file-based system. But it's not the only negative. We've also got a concept called data redundancy. That's a big word. Let me say it again. Data redundancy. What do I mean by that? Well, do you notice how we've got customers which are repeated? So we've got Mr. John Smith here, we've got Mr. John Smith here, we've got France here, we've got France here. So data's being repeated. That isn't our issue. But what happens if data changes? So Rachel Smith got divorced. Her name is now, since she became a customer, Miss Rachel Ebanks. So we've got an Ebanks here, we've got a Smith here. They're 2 different last names. It's also Mrs. Miss. So we call this a data redundancy issue. The data now is not accurate, it's inconsistent. We made a change on this file because we noticed she's now divorced since she made a booking. So she made a booking in October, she's going on vacation in March, she got divorced in December. So we've updated it here but not updated it here, so we've got some redundancy there. This basically means that a staff member has to manually update this one as well if they remember to. It's the same with Miss Katara. Miss Katara got married to Joe Ang, or Ang. Joe Ang is now married to Mrs. Ang, so we need to update this, which has been updated, but this one has not been updated. It's still Miss Katara. We've also got an issue where it comes to, we've got Sweden here, but we're not going to Sweden in our destinations, so we've got some inaccuracies there. So data redundancy, and I'll give you some definitions in a bit, is simply where our data is inaccurate, it's appearing in multiple places, and changes are having to be done manually, but are leading to mistakes. And because of this, and because we're using a manual system, this is all manual, us having to type these updates, it's me having to do it. It's going to lead to not just data redundancy, but also inefficient data handling. Why? Well, if I wanted to search through all the bookings, as I mentioned, we're going to have to do that bit by bit manually. So if I said, find me everyone who's going to USA, this is easy. You can just say one person, two people. But if you had 10,000 customers, it makes the game a lot harder. So it's not that efficient for us to search for data, query data. I'm hoping you've seen where this is leading to. So at the moment, it's not easy for us to search, sort data. If I said, let's sort the data out in alphabetical order, it's going to be hard to do. But not just that. We could also have data in different formats by mistake. So what happens if somebody, for the customer, was to write in doctor like that with a full stop versus doctor like that versus doctor just like that? A human could quite easily enter it like this once, enter it like this another time, enter it like this another time. That means mistakes could be made. So we can have inconsistent data formats. That basically means it's going to be hard for us to search for information because it's inconsistent in the first place. What happens if our team grows and we've got, let's say, 30 people working for me, making bookings? Are we able to have 30 people accessing these files all at the same time and making updates? It's not made for that. So we're going to get issues with multi-access. What we might get is read-write issues. So whilst I'm making changes, you're not allowed to make changes. So imagine that you've got 30 people wanting to make bookings. I'm currently on the phone taking a booking from a customer. I then enter the information onto the system, but you are also on the phone to a customer, but because I'm entering data, you're not able to. That's because this file-based system isn't made for multi-access, so limited accessibility. And it's the same if you want to update information or whatever. And finally, all of us can have access to the same information. But let's imagine we had payment details. So if I just zoom out slightly. So let's add payment. Would I want, like, my ground floor shop workers, the guys who are like on the phones, to have access to people's payment information? No. I am the owner. I want access to their payment information because I care about that sort of things. But these guys shouldn't have any access to that. But because we're using this file-based system like Microsoft Word documents to store the data, security is pretty poor. It could lead to breaches, misuse. So this is what we've got so far with our file-based system. Disorganized data redundancy, inefficient data handling, inconsistent data formats, limited accessibility, and poor security. So what can we do about it? Well, folks, That is where databases come into it. Dun, dun, dun. Shock, horror. Okay, so we can lead to the database management system. We call this Dbms. I'm not going to talk about the vacation company anymore, the holiday company. Let's talk about Disney. We all love a bit of Disney, don't we, in our lives? So take Disney. Disney have a giant database. I'll put DB for database. Disney use what is known as a database management system, which consists of all these different features. And what I'm going to do is I'm going to talk through these different features bit by bit. So hopefully you've got a good understanding of how this all works. So to begin with, the database. Well, data management allows for us in our database to have data. The data of our customers for Disney. These customers are stored in tables. And it's relational. So we call this relational database. It's where you can have one table linked to another table, such as the one-to-many relationship, which we've looked at previously. This database is actually stored on different hard drives and SSD. So that is data management. It's the storing of customer data. It's stored on SSDs, secondary storage devices. This allows it to be accessed really easily. It's stored in tables. These tables are part of a relationship. So part of what we can say is a relational database, where we've got, as I just said, tables which are linked together. So that is data management. So what is data dictionary? So this is a data dictionary, but I'm going to add some more details to this, where you would have the different tables, the different fields you would have, but also the different data types. So this would be no doubt an integer. This would be a varchar. So you would have the data types. Not only will you have the data types, but you'd also have an understanding of how the tables are related together. So you would have like a diagram form of the tables. I guess it's kind of what you have now, I suppose, on the screen here. So the data dictionary is known to be what we call the meta data of the database, or for the database management system. What does metadata mean? Well, it means basically a description of the data in the database. That is metadata. So it's a guide, basically. It's a guide to help different designers and developers to help code our database and structure it. It's a blueprint. That's a good way of thinking about it. So the data dictionary is metadata for a database management system. It's like a blueprint. It contains different things such as the field. So the names of the fields, shall I say, the table names. It could also contain meta information about any validation you're using. So validation rules, length check, range check, etc. It would also have identified different primary keys which are being used in the tables. And also it would discuss or describe any relationships between the tables. And there you go, quick snapshot. So in the database management system, there's also a different number of ways we can actually model our data. What you see on the screen right now is for a store. This store is selling shoes. And the way this is being organized is using some sort of what we call hierarchical model. So we've got like a king, and it's got like its servants underneath and servants under that. So what we have in essence is we can represent the relationship between the shoes on a shopping website, which we can see right now that from this example we have a node for men's shoes, and we know that for men shoes, you can have a type called sneakers or a type called sports shoes. I'm not sure of the difference between sports shoes and sneakers. Are we talking about like football boots? So from this, we can see that sneakers are part of men's shoes. Men's shoes are part of shoes. And we can go the other way as well. We call these child nodes. So this is a child of shoes. This is a child of men's shoes. This is a node. This is a node. So each child node, such as sneakers, has a parent node. A parent node can have multiple child nodes. So we've got 1, 2 here. So we can have multiple kids. What we can't have is multiple parents. So we can't have sneakers having men's shoes and women's shoes. There'll need to be a different category over here for sneakers if we wanted that. And what we're seeing right now is a relationship. We're having a relationship between the types of shoes, the category. So this is one way we can model our data. So the whole point of database management modeling allows us to very simply analyze our data objects and identify any relationships. So by me recognizing, uh-oh, what about sneakers for women? There you go, got a new relationship, new node, new relationship just been formed. It gives a very nice overview. But there are other types of models. This is called the entity relationship model, not the entity relationship diagram which we've used before, where you've got like a one-to-many relationship between the tables. No, no. This is looking at the relationship between the data, not the tables. So what we can see right here is that we have the attributes of teacher and department. And you can call these, in essence, tables. Table, table. So teacher works for a department. So every teacher works for a department. So we've got a relationship there, we can see it. But we can also see through this that every department has an ID and every department has a name. Every teacher has a salary, an age, and a mobile number. That's cell phone for you Americans. They also have a teacher name and teacher ID. So it gives us another way, as I said a minute ago, to organize our data objects, to analyze it, and identify relationships between them. And that is what data modeling is all about. So we've next got the logical schema. That sounds complicated. Let's have a look at that and a little bit more information. This is actually dead easy. This is the logical schema. It's an overview. It's an overview of our database. We can see all the tables, we can see all the fields, but we can also see how each table is related to another. So, for example, we have a table with students. We've got a table called marks from a test. What's the relationship? It is one student can have many marks. So one student, many marks. As a developer, I can code that. I could also see as a developer what the primary key field is and what the foreign key fields are. And that is part of our logical schema, looking at the entities, the tables, the attributes, the fields, and also their relationships. This is different to data modeling because we're looking at the relationships between the tables and not the fields. Whereas with data modeling, we looked at, if I just make this a bit bigger, the relationship between the fields and the tables and each other. So you've got entity relationship models and you've got entity relationship diagrams. So again, the logical schema is all about, very simply, the relationship between the tables. It shows us all the attributes, and it shows us an overview of all the entities as well, all the tables, in a nice way. So normally what would happen is you would have an app, an application. So let's imagine it's the Disney Plus website. It'll be connected to the data management system. On this website, you can allow customers to use it, but also people who work at Disney. So the employees at Disney Plus. Now, using this database management system through this application, we're able to access the same data all at the same time. And that's what we're looking at now with data integrity. If you remember the first video I did on file management, with that, it basically allowed, well, it didn't allow multiple people to work on the same file. So we had a file here, a file here, and it wouldn't allow multiple people to make edits. With database management systems, we can have many people working for our company, and we can have them accessing the data. Now, I'm making changes. So if this person's making a change to the data, this person can also access that data. They may not be able to do anything, but they can still access it at the time. So it stops any conflicts from happening. It basically blocks anything. So let's imagine right now that this person here is changing the name of a customer. They got married from Joe to Bo, little Bo. When they make this change, this worker will have it on their own computer, this change. When they're done, it then uploads it to the database itself, to the data management system. So the database management system allows us to make changes locally on our own computer, put it onto the main system, and it stops any issues in terms of data integrity. That's mistakes with data. But not only that, not only does it offer data integrity, it also offers data security, because we can now basically have access rights for different groups of people. So this person is the owner of Disney. He is going to get access to lots of different things, such as payments and credit card details, staff wages. This person here is just a regular call center person. They will only have access to customer details and movie details. They will not be able to access staff wages or any of the customer payment details. That's because of access rights, which database management systems create for us. We then have data change class solution. So this is basically building on our data integrity, so when we make changes. So let's imagine that this is our database table. We've got name, and we've got age. And we've got a person called Joe, and they're 11 years old. I keep using the name Joe, I don't know why, so let's do John. Our employee, A, is wanting to change John's age to 12. We also have someone called Mary, who's 14. Employee B is wanting to change Mary's details to 15 because she's got a year older. A accessed it first, A can change it to 12. Person B, employee B, won't be able to do anything because it's locked. The table is locked until A has finished making their changes. As soon as A says I'm done, B can then change this to 15 years old or whatever. So it stops any potential clashes because we don't want them both changing the same information, let's say that, at the same time. That'd be stupid. So A changes it to 12 and B is trying to change it to 12 at the same time. They don't realize that one of them's doing it already. So it locks the other person out until the changes are made. And finally, we've got database management system tools. So Disney will have their website, Disney Plus. They also have their theme park website. These are both what we call applications. What happens is that they're both connected to the database, the same database. Even though the Disney Plus website looks completely different to the theme park website. So as you can see, they're two different looking websites, but the database driving them both could be the same. Facebook do the same, where you've got your database. You've then got Facebook itself. You've then got WhatsApp. You've then got Instagram, all sharing the same database. So what we have here is a developer interface for databases for my database management system. So I can make a table without doing any SQL. So I can do a table called animals. I can have a primary key field called animal ID. Let's make it go up by 1 each time, auto increment, make it primary key field, animal name. Let's make it varchar 255. Okay. If I run it now, I'm going to put some data into it. So instead of doing an insert query, I can just do this. I can do a Phillips animal. That's his name, Phillips. Let's do another animal. Let's do insert, and let's do a donkey. Done. So again, I don't have to do any of the query work. It's done it for me in my developer interface. I could also do things like delete tables. I don't need to write the code to drop a table. I just click on the table and I'll click on drop and it will go bye-bye. Happy, happy days. But also, this software does do a nice query processor. So if I just quickly make a table again called animals, and we do ID, and I'm going to do animal name, and make that varchar 255, make this auto increment, save, and then it's insert donkey, and I'll do SQL. I could use this query processor, which helps me build the perfect query. So it optimizes it. So I'm going to use that word. Optimizes the query. It also will then execute the query. So for example, if I did select or from the table animals, it'll now execute that query. There we go. We see donkey. Happy days. So this is, actually you won't be able to see that because it's off the screen. So let's do this. There you go. You can now see donkey based on this query. ID 1. So this is an example of the Dbms tools. So we've got a developer interface, which allow me to very easily create and use DDL and DML, and a query processor to execute high-level queries. And also we've got the application layer, which sits on top, which talks with the database and the database management system. So it all works together. So let's have a quick recap on each one of these features that we see on the side. So we have the data management system. As I mentioned right at the start, data management is basically the relational database, organizing tables stored on secondary storage. We've got the data dictionary, which is the meta information about the database, such as the tables, the field names, the data types, and relationships. We've then got data modeling, which is modeling relationships like using the hierarchical model or using the entity relationship model. You've then got logical schema, which is showing the relationship between the tables, and an overview of the database using this entity relationship diagram. So not model, diagram in this situation. We then talked about data integrity, which is very similar to data change slash clash solutions, and very similar to deadlock resolutions, where you have multiple people on the same data, stops people from making errors or changes when you're doing it one at a time. So it allows multiple people to view data, but locks people out when you're making changes. We then talked about data security when we talked about access rights or group rights, so that people can access certain tables, do certain functions. You might have some users who can't see tables like that, they can't see it, or they might be able to see this table marks, but they won't be able to make any changes to it, no changes. We then talked about Dbms tools, such as the developer interface and the query processor. There will be a knowledge organizer down below.